One-to-one functions and their inverses. A function is a formula that has only one y, or outcome, for each x, which is the input. In other words, given a set of points from the function, the x's will not repeat. However, it's still a function if the y's repeat. Each y value can have more than one x value. A parabola is a good illustration of this. So if you look at the first graph with the parabola, notice when y equals 4, there are two different x values, once when x is 2 and once when x is negative 2. So there are two x values for the y equals 4. So this is a function. The vertical line test can be used to determine whether a graph represents a function. A vertical line passes through this parabola, vertical, remember, straight up and down, without touching it in more than one point at once. So if a graph passes the vertical line test, it's a function. If the function has only one y for each x and also only one x for each y, then the function is said to be one-to-one. So for this parabola, it would not be one-to-one, since there's two x's for one y. To decide if a graph is one-to-one, it will pass both the vertical and horizontal line tests. Let's look at the graph on the bottom left. A vertical line passed across the graph will only touch the graph in one point at once. But if you do a horizontal line across the graph, and if you get up right here in the middle, you can see it can cross the graph as many as 3 places at once. So this graph is a function. It passes the vertical line test, but it's not one-to-one. For the last graph, a vertical line passing across would only touch the graph at one spot at a time, and a horizontal line passing up and down would only touch the graph at one spot at a time. So it is a one-to-one function. Now let's talk about inverse functions. Two functions are inverses of each other if f of g of x equals x and g of f of x equals x. So we're going to algebraically show that these two functions are inverses. We're coming in with the understanding that they are inverses. We're just going to prove it. So first we do f of g. And remember, when you do f of g, you plug the g function into f everywhere you see an x. So if I look at the f function, I have a 2, and then where the x is, I replace it with g, x plus 5 all over 2. And then we still have minus 5. Now simplifying that, the 2's would cancel, and you have x plus 5 minus 5. The 5's would cancel, and you're just left with x. And that's what you want. That's what should happen, or you've done something wrong. Then we go the other way around. G of f, the one on the right, plugs into the one on the left. So we have a fraction, and where the x is, we replace it with the f function, 2x minus 5. And then we still have the plus 5 over 2. So the 5's would cancel. You're left with 2x over 2. The 2's cancel, and you're just left with x. So because f of g equals x and g of f equals x, we've proven that the two functions are inverses. To find the inverse of a function algebraically, it's a two-step process. First, you switch the x and the y, and then you solve for y. And so in this example, there is no y, but remember that f of x and y are interchangeable. Step 1 is to switch the x and the y. So now I write x equals 4y minus 3. And step 2 now is to get the y by itself. So let's add the 3 and then divide everything by 4. And you could do the terms individually by 4 and have x over 4 plus 3/4. That would be fine. Or you can just keep it all one fraction. And so that's the inverse. And the f with the little -1 is the notation that means inverse. This example is a bit more difficult. Same instructions, so we have y equals 2x plus 5 over x minus 7. And the first step is to switch the x and the y. So x equals 2y plus 5 over y minus 7. Now this problem is much more difficult because of the two y's. The process used for this problem is a process that comes up in specific type of calculus problems. So I want to get the y by itself, but there's two of them. The first step is to wipe out our fraction. We're going to multiply both sides by y minus 7. And so we have x times y minus 7 equals 2y plus 5. Distribute the x. xy minus 7x equals 2y plus 5. And this is usually where everybody gets stuck. So here's the trick to this. For the next step, move every term that has a y with it to the left side. Everything else should go to the right. So my 2y needs to move to the left side. The 7x needs to move to the right side. And of course, they change signs when they move. So we have xy minus 2y equals 5 plus 7x. Now on the left side, both of those terms have a y. So we can factor out a y. Put the y out front of the parentheses and divide, and you're left with x minus 2. And now you can get the y by itself. Divide both sides by x minus 2. And so the y will be by itself. Our inverse is 5 plus 7x over x minus 2. An easy way to sketch a graph of a function and its inverse is by making a table and plotting points. So for this example of 9 minus x squared, we're supposed to A, sketch the graph of the function f, B, use the graph of f to sketch the graph of the inverse, and then C, find the inverse. So at first we're going to make a table for the original function a, and because it says x is greater than or equal to 0, then we start with 0 on the x column and fill in some more numbers that are bigger than 0. And then one at a time, you're going to plug those numbers in for x to get the corresponding y values. Now on the graph in black, I've plotted those points, and you can see that curve heads down. Then to do the graph of the inverse, you switch the x and y values from the table. So the y column becomes the x column becomes the y column, and that graph and the graph below is the graph done in red. And just so you can see that if you've done it right, I've drawn the dotted blue line, diagonal line through the middle, which is the graph of y equals x. Functions and their inverses are always symmetrical around the line y equals x. And then we're supposed to find the inverse of the function f of x equals 9 minus x squared. And so that's y equals 9 minus x squared. We switch the x and the y. And now I want to get the y by itself. So I'm going to move the y over to the left side. Subtract x. And then we would square root both sides to get the y by itself. So y is the square root of 9 minus x, and that is the inverse.